Okay, hi, a very good day, everyone. Today we are going to proceed on to 3.5 compound interest. And compound interest is actually a way in which we save money and in which we calculate how much we have by the end of a year or a period of time. Alright, it's a very different way as compared to simple interest, where simple interest is just based on the original sum of money. You're just going to collect interest based on that money itself. Alright, but for compound interest, we will calculate our interest and we'll calculate a growth of our investment or the savings, right? Or maybe a loan in a different way than the simple interest. So let's take a look at how we calculate our compound interest and what is the mechanism. Alright, so example, we want to invest $1,000 into a bank. The interest rate is about 2% per annum, and per annum we mean yearly. Right, compounded annually means every year we will raise this by 2%, and this will last for a period of 3 years. All right. Okay, so let's take a look at what happens now at the end of year one. Right, the amount we have is just $1,000, and we raise by 2%. Correct. So the whole amount we multiply by 102%, and but so this is our 102%, but this also means that we multiply by 1.02, right? As we've learned in chapter, I think sec 1, if I'm not wrong, 102% is just 1.02 as a multiplier, right? Then at the end of year 2, we are going to take the same amount over here, right? We're going to take the same amount in year 1, and we're going to raise this by another 2%. So the entire thing, the entire sum that I have at the end of year 1 is going to raise by 2%. So the whole thing multiplied by 1.02 again. And if you see both of these, right, we can actually combine them into index notation, and it will be 1.02 square. Right, moving forward, at the end of year 3, we can take the same amount again, right? 1000 times 1.02 square. The whole thing raised by 2%. The whole amount raised by 2%. So this whole thing times 1.02 again, you get 1000 times 1.02 to the power of 3. Now, if you are very interested in how much it is, we then can use our calculator to evaluate and see that this is 1061.208. Okay, so after 3 years, 2% per annum, compounded annually for 3 years, we have $1,061 roughly. Okay, now so this is a little bit different from simple interest, where you just the interest is calculated based on the original amount instead of taking the whole thing and multiply by the interest. Okay, so for a very quick recap, let's take a look at how does a simple interest work again. Alright, so same thing. If we look at the simple interest, we only have $1,000 at the beginning, and this is the interest proportion. We have the 1,000 times 2% every year times 3 years divided by 100, because it is 2%, 2 over 100. Okay, so we have the original amount plus the interest based on the original amount, which is 1,060. Okay, from here it does not look a lot. Okay, but if you were to do this for maybe 10 years, 20 years, compound interest will actually give much more return as compared to simple interest. For now, like 2-3 years, the effect not so much, but over time, the compounding effect will be a lot. Okay. Okay, and with this, we have our formula for our compound interest, which is A equals to P times 1 plus R over 100 to the power of N. Alright, so over here, let's take a look at what each of these letters mean. There's a lot of variables inside. A would be the total amount of money. Right? P would be the principal amount. Principal means the original amount. Right? The original amount, or the original amount that you loan or you put into the bank or invested. R would be the interest rate per cycle. For every cycle, there'll be an interest rate. N would be the number of cycles. Alright, so if you want to compare, right, if you want to compare with the one above, right, over here, okay, if you want to compare with this one above, you can see that we are looking for the total amount, right? We are looking for the total amount. P would be the original sum that we've input which is the $1,000 that we invested. Now this one is interesting, the 1 plus r over 100. So this is 1 plus 2%. So 1 plus 2 over 100, okay, would give us 1.02. Alright, so this thing over here will be 1 plus the interest rate over 100, so 1 plus 2%. So it means it will be total 102% over here. Okay, so this one over here, this is actually the interest, the portion, the component for the interest. And last but not least, our n, which will give us the number of years that we invest, or the number of cycles to be more precise. Okay, so this is the formula that we will be using throughout for this compound interest. Alright, let us continue with practice now 14, and let us try and see how this works. So once again, you can copy down and refer this to your formula then and again. Alright, so number one, find the compound interest. So we are only looking for the interest on $3,000 for 4 years at 5% per annum compounded annually. So over here, if you want to write down the individual values, the what information we have is the principal, the original amount is going to be $3,000. The number of years is going to be 4 years, and we have interest rate of 5% per annum. Okay, and we compound annually. So this compound annually is very important. Okay, compounding annually is very important. Okay, so without further ado, let us take a look at how do we use the formula over here. Alright, so A would be the total amount of money. So the total amount of money would be like this. The principal, 3,000. We have 1 plus 5% over 100 to the power of 4. Okay, right, so if you can see, right, what we're doing like above is just 3,000 times 1.05 to the power of 4, right, as you can see over here. Now based on the calculator, my final answer would be, okay, so I have 3646.5188. Okay, alright, then last but not least, because the question is looking for the interest, so the interest alone, the compound interest alone, right, would be just this sum, right, would be just this sum minus of my original $3,000. So this would give me $646 nearest cent, so 52 cents, like that. Okay, so this is for question 1, compound interest. Okay, now let's take a look at number 2. Same thing, we are looking for compound interest on $1,500, 2 years, 2% per annum every year, compounded annually. So we are going to compound this annually. So it means that I'm going to just use this formula, right? P, the original amount, raise this by 2%, right? And compound over 2 years. So this one will give me around, 1560.60 cents. Okay, so the interest that we're gonna get, right, is, because we're only looking for the interest, so we need to take this total amount, right, we need to minus off the principal value, minus off the original sum. So we have $60.60, okay, as the interest. Alright, so for part B will be the interesting one, right? Part B, the principal amount is the same, okay, however the interest rate is 2% per annum, correct? So 2% per annum, but this is for 1 whole year. So for every month, I'm going to have 2% divided by 12 for every month, right? So this will now, instead of per year, I need to convert this to per month first. So every cycle now will be every month. Now in the same way, N is also 2 years, right? N is also 2 years, But how many months are there in 2 years? So here I need to multiply by 12 months. So in total I have 2 times 12 cycles, or 2 times 12 months. So I'm going to plug this into the formula over here. Right, I'm going to plug this into the formula here, and let's see how it works over here. Right, let me zoom in a bit. So I have an original amount of 1,500. I have 1 plus, now 2 over 12, right, times 100, and the n would be 2 times 12 months, right? So here will be 24 months. Okay, so over here I have 1,500 plus 1 plus 2 times 2 divided by 12 divided by 100, and this is raised to the power of 24. So over here I have 1561.164. Right, so our interest is 1561, our total amount that we've gotten back, right, minus off the original sum of 1,500 over here. So we have now $61.64 as the interest. So as you can see, this one over here, right, this one over here, and also the first example is a slight difference where you talk about the frequency where you compound. So if you compound it slightly more often, then you will get slightly more a bit. Okay, there's a certain limit to it which we will explore in a future topic, but for now there's a slight difference in the when you compound the compound your interest in a different period. Okay, so now let's take a look at our final example over here for question 3. Okay, we have Varney placed $4,000 in the bank for 4 years. Bank offers an interest compounded yearly. So this is important. So the now the period or the timing that we compound is a bit sensitive, whether we compound yearly, half a year, or every month. Okay, and we need to adjust the R and the N appropriately, right? So but this one we are safe. At the end of 4 years, she received this amount of money. So find the interest rate. Okay, nice. So for question 3, the principal amount is $4,000, right? The interest rate is something that we need to find. The number of years is 4 years, right? And she receives a total. So the total amount is 4502.04. Anything else that we have? Okay, and then just to confirm, we are compounding yearly, and the interest rate we want is per year. So there's no fancy gimmicks over here, unlike the B earlier. So let us make use of our formula. A equals to P 1 plus R over 100. So this is the interest component raised to the power of n, number of cycles. Okay, so we have sub in 4502.04 is equals to 4,000 1 plus R over 100 to the power of n. So what do we do first? Because we want to make R the subject, we want to solve for R. So we have something times this. So what do we remove on the outermost? We can remove this 4,000 over here. So when you divide both sides by 4,000, right? You can, so what you can do is you can divide this thing by 4,000. You will get your 1 plus R over 100 to the power of n. So okay, so you have your 1.12551 is equals to this thing over here. Okay, so divide by 4,000. Right, so what we can do next, the outermost now is our n. Oh wait, our n, we forgot to sub in. N is 4 years also. Right, n is 4 years. So how do we get rid of the 4 years? We need to take root 4, fourth root to this thing. Right, so this one, we will need to take the fourth root to 1.12551. So this will be equals to this amount. Okay, so the fourth root of 1.12551 is actually 1.03000 and so on. Okay, right, so we got this over here, right? So minus 1 on both sides, we have something like this. Now we can minus 1 on both sides, and we can multiply this by 100, right? So therefore, my R is roughly 3% per annum to 3 significant figures. Okay, so let me show you the full working again. Right over here, so we have this, right, scale all the way down to 3%. Alright, so that's all that we have for this video. Thank you so much and have a nice day.